Hello, team. This is Aziz. It was great spending time with you during the Python for data science section, and I have put this short walkthrough together to highlight how Python can support your operational workflow, especially in the area of forecasting, pattern detection, and also automated reporting. This is a very concise version of what we explore during this section, but focus specifically on how this analysis tie directly to operational decision making. So the first thing I will do is to locate the repo for my account, forecasting sales, and I'll copy the web link so that I can use it for cloning. And I'll be using the Jupyter notebook. So I have the couple of files, which is the data sets and the charts that I created, which I'll be showing you how to do that also. And so I will open the forecasting Jupyter notebook. So the first thing you want to do while working with a Python for data analysis is to import the necessary libraries. So I import the necessary library that will be needed for the analysis. Then I import my data sets and I try to make a copy of it and save it as sales. And we have a couple of variables. So I only needed the date and total sales. So I make a copy of that. Then I try to clean the data sets as needed, remove some characters and some invalid uh, values. And for easy computation, so I will scale the total sales to in a decimal place, like divide by 1 million each. And here is the information about the data set. That is, its range is span from 2021 to 2025 of December, and it has 60 rows of column because it's 60 entries. That's 5 years of data. That is 12 months each in each year times 5. That's 60. So I did some analysis, exploratory data analysis to see the pattern in the total sales across the year, and I observed that there's an upward trend over the year from year 2021 to 2025 of December. So I printed out some metrics and I created functions so I can use to plot a chart, and I calculated the MOM growth rate and I plot the charts, and we see downward trend on that. Also for MOM absolute growth, you can see the spike and it stables over there, although it has some spikes in the early year. I also calculated year-on-year growth rate, and we see the chart also, and which has downward trend, and I added some insights I derived from the chart. So before I perform my model, I split the data into two. That is, I'll be using some parts for training and the other one for testing. So I'll be able to evaluate the performance of the model. So for visual improvements, so that we can have a better understanding of what I did here, that is splitting the data set. So I plot a chart and use a dotted line to denote where I'm splitting the data from. That is, the orange line represents the test data, while the blue line represents the training data set. So I use Holt linear model here, and at first I pass in the default settings for the model. So after building my model, I try to forecast and test test it against the real actual data. That is, I use this data 2021 to 2025. Then the model performance, I use it to forecast from 2025 of January to 2025 of December. Then I pick the values, that is the forecasted values. I I put it together with the actual one, that is the actual 2025 that we have. So I thought that there is some disparities, that is the model is not 100%. So I printed out some evaluation, that is mean absolute error, root mean squared error, and also mean absolute percentage error. And here are the metrics, which we have 0.1%. And we can say for every 1 billion, that is 10% average error we'll be getting from there. And I look at the metrics, and I see that I can improve that. So, but before I did that, I tried to plot the forecasted data against the actual that we had initially. And because the error margin is very, very low, so it's very, very low of 0.1%, 0.10%, I mean. So it covers the actual data set, but from the metrics, we see we still have error. So I have to find the best parameter. So I did a pattern parameter research, and I donate the parameters I'm looking for as best alpha and best beta, which I'm saving the values that I get there. I'll be using it for my smoothing level and my smoothing trend. So I run a loop to find the best parameters. So after I find the best parameters, here we see the best alpha is 0.8 and best beta is 0.4, which the main thing we are looking for is 0.0, that is zero errors. So I take the value and I slide it into the new model that I built. So after building the model and trying to run a forecast with the same data, that is our test data, and here is the result. When I try to subtract it from the actual one, you can see we have zero errors, that is, it's 100% accurate. And here are the metrics. Then after I still plot the chart again to see how it looks visually. So after running the model against the training data, and because we have 60 data rows of data, that is, we have 60 months, and I've used 48 of them for training, and I used the remaining 12 for testing. After finding the best parameters to have the 100% accuracy, so I still run the model on the whole data set, and now I plot for the year of 2026 of January to December of 2026, and here I save the data sets as reports, that is the calculation that I made and everything, and the forecast data. I save everything as report data, and also I use timestamps so that every time I'm saving the data set, it will comes with the time that the code was run, that is the program was run. So with this information, I'll be able to track my metrics so that the data won't mix together. I also save the model for reuse, and also I plot the chart, and here's the chart. And I know that this chart can be used in presentation, so I save the chart also, and I still have a timestamp. And let's take a look. So this is how the chart comes up. The chart is being saved, that is forecast chart 2025 and the current date time. So I did the same thing for the forecast data, also for the model. So I can download this file that I've just saved from the analysis, So let's take a look at the reports forecast data. And also this can be downloaded and open with our spreadsheet. So this download. So you can take a look here. So we only started with dates and total sales. So we created the sales in billion, that is for easy computation. I calculated the MOM and the year-on-year growth rates. And here is the data. So if you scroll down, we see our forecasted data for 2026 of January to 2026 of December. As you can see, here's the data. So I can still open the forecast data here with my spreadsheet. Maybe I want to share with someone, with my colleagues. Second screen. So this is how the data sets that I saved from the programs look like. So we'll take a look. We have data from forecast data from January 2026 to December of 2026. And we can take a look at the forecast charts. Okay. And also we can also download the forecast chart also. So this is good for presentation. And also we can save this analysis as PDF. Maybe you want to share with someone else and they don't have to run the code by themselves. They'll just take a look. So we look for download here. This is what I want to download. No. Okay. Save and export as. Okay, I didn't run this code, so we can save as our PDF or any other format that we want. All right. If the team is interested in the next step, this same workflow can be extended with AI-driven capabilities. Let's say, for example, we can automate anomaly detection that flags unusual demand pattern and intelligent forecasting that adapt as new data-driven and also decision support model that can recommend action rather than just reporting outcome. And also, by embedding these capabilities directly into the existing operational process, Python and AI can move the organization from reactive reporting to proactive one and data-driven operation. I'll be glad to support the team in designing and implementing this evolution. Thank you again for this opportunity to collaborate.